You are moving forward in time right now, whether you like it or not, and there is absolutely nothing you can do to stop it. You cannot pause it, rewind it, or even slow it down. Time does not ask permission. It simply drags everything with it, from collapsing stars to your half-forgotten memories, and it never looks back. What makes this unsettling is not that time moves, but that it moves in only one direction. Eggs break, but never unbreak. People age, but never grow younger. Fires burn out, but ashes never reassemble into wood. The universe seems obsessed with going from order to mess, from structure to chaos, as if it has a personal grudge against neatness. And the strangest part is that the fundamental laws of physics do not care which way time goes. On the deepest level, most equations work just fine, forward or backward. The universe, at least on paper, has no preference. Yet reality does. This one-way street of time is called the arrow of time, and it is one of the greatest unsolved mysteries in science, not because we do not have ideas, but because every idea leads to an even deeper question. The most popular explanation involves entropy, a measure of how disordered a system is. Entropy tends to increase, not because it must, but because it is overwhelmingly more likely. There are more ways for things to be messy than tidy. A shuffled deck of cards can exist in countless random arrangements, but only one perfect order. Given enough time, order almost always loses. But here is the problem that keeps physicists awake at night. Entropy explains why the future looks different from the past, but it does not explain why the universe started in such a ridiculously low entropy state in the first place. The early universe was smooth, simple, and eerily well organized. That should have been astronomically unlikely. Yet without that improbable beginning, there would be no arrow of time at all. No stars forming, no memories, no cause and effect. Just a timeless fog where nothing truly happens. This leads to an uncomfortable possibility. Time might not be fundamental. It could be a side effect, an emergent phenomenon, like temperature or pressure. On the smallest scales, the universe may not know what time is. Some theories suggest that at the deepest level of reality, everything simply exists all at once, frozen in a giant mathematical structure. Past, present, and future laid out together, like pages of a book that only feel sequential because your mind flips through them in order. Your brain plays a cruel role in this illusion. Memory only works in one direction. You remember the past because entropy was lower there, allowing information to be stored. You cannot remember the future because it has not become disordered yet in the right way. From your perspective, time feels like motion, but it may simply be the process of information degrading. You are not traveling through time. You are dissolving with it. Even more disturbing is the idea that the arrow of time might be local. In some distant region of the cosmos, time could flow the opposite way, with entropy decreasing instead of increasing. From the inside, that region would feel perfectly normal. Beings there would remember what we call the future and forget what we call the past. To them, we would look like creatures living backward, convinced that broken things cannot fix themselves. And then there is the ultimate question that refuses to go away. If time had a beginning, what came before it? If time emerged from a timeless state, then cause and effect break down at the very moment we need them most. Something happened without time for it to happen in. The universe began aging without ever being young. Time only moves forward because the universe allows it to, or perhaps because it has no other option. And if the conditions that gave birth to this arrow ever change, time itself may lose its direction. When entropy reaches its maximum, when everything becomes evenly spread and nothing meaningful can change, the arrow of time may simply fade away. Not with an explosion, not with a final moment, but with silence. Imagine a universe where nothing ever truly happens. Not because everything is frozen, but because there is no meaningful difference between one moment and the next. This is where the arrow of time is pointing. If entropy keeps increasing forever, the universe drifts toward a state of perfect balance, maximum disorder, and total boredom. No gradients, no energy flows, no change worth naming. Time does not end with a bang. It ends because it has nothing left to do. This future is known as heat death, and despite the dramatic name, it is terrifyingly quiet. Stars burn out, black holes evaporate. Particles drift apart until interactions become so rare they might as well not exist. Without change, time loses its grip on reality. If nothing can happen, the difference between before and after becomes meaningless. Time, as we understand it, dissolves. But this creates a deeply unsettling paradox. If the universe naturally evolves toward maximum entropy, then a universe like ours, so structured and energetic, should be extraordinarily rare. And yet here we are, early in cosmic history, surrounded by stars, chemistry, and complexity. This has led some physicists to suggest that our universe is a fluctuation, a temporary deviation from equilibrium, a brief rebellion against timelessness. Others go further. They propose that time itself is not universal, but conditional, that it only exists where entropy is rising. In regions where entropy is stable or decreasing, time may not exist at all in any meaningful sense. There may be vast portions of reality where asking what happens next is a meaningless question. Then there is the most disturbing idea of all. The arrow of time may be connected to consciousness, not because the mind creates time, but because awareness requires asymmetry. To think, to decide, to experience, there must be a difference between what was and what could be. A perfectly symmetric universe might be real, but it would be unobservable. Nothing inside it could notice its own existence. This raises a brutal possibility. We experience time moving forward not because it is a fundamental feature of reality, but because only in such a universe can observers exist. We are not watching time pass. We are a side effect of the conditions that make time feel real. If that is true, then asking why time moves forward may be the wrong question. The better question might be why anything exists that can notice time at all. Why there is something instead of a timeless, featureless nothing. Physics has equations. Cosmology has models. But none of them fully explain why the universe began in a state that allowed time to have a direction. Time moves forward because it started broken, because the universe began uneven, unbalanced, and full of potential. And as that imbalance slowly fades, so will the very thing you feel passing every second. One day, far beyond any future we can imagine, time may stop not because it is forbidden, but because it is no longer possible. Time may feel like a river, but rivers need a slope. Without it, nothing flows. That slope is entropy, the quiet rule saying disorder prefers tomorrow over yesterday. Every broken cup knows it. Every aging cell proves it. But here is the uncomfortable part. The fundamental laws of physics do not care about direction. They work almost perfectly, the same forward and backward. Remove friction, remove noise, remove memory, and time loses its arrow entirely. So why do we experience it so stubbornly one way? Because we remember the past, not the future. Memory itself is an entropy machine. To store a memory, the brain must increase disorder elsewhere. Every thought you keep costs energy. Every moment you remember pushes entropy forward. In that sense, time moves forward because minds exist. If there were no observers, no records, no traces, the universe would still obey equations, but it would not feel like a story. It would be a frozen book with all pages written at once. This leads to a disturbing idea. The flow of time may not be a property of the universe, but a side effect of consciousness trying to survive. We experience now because our biology is tuned to extract meaning from change. Past is what left scars. Future is what has not hurt us yet. The present is the narrow slice where prediction meets damage control. And then there is the far future. As stars burn out and matter thins, entropy approaches its maximum. No gradients remain, no energy differences, no processes. In that state, time does not stop with a bang. It fades. Without change, seconds become meaningless. A universe at maximum entropy cannot tell yesterday from tomorrow. The arrow dissolves, not because physics breaks, but because nothing is left to point. Some theories suggest time might reverse in distant regions. Others suggest new universes where entropy starts low again, birthing fresh arrows, fresh directions. If so, time is not universal. It is local, temporary, fragile, a feature, not a foundation. So why does time move only one way? Because the universe began in an absurdly ordered state. Because disorder is statistically favored. Because memory is expensive. Because existence itself leaks energy. Time is not marching forward, it is falling downhill. And one day, when the slope is gone, time will not reverse. It will simply stop being a question worth asking.